Hi, this is Hema Kadia from TeckNexus. Welcome to the 5G Fireside chat series. Our today's topic is physical network function and its relevance and support in 5G networks. For today's session, we have invited Sriram, who is co-founder and head of engineering at Arna Networks. Welcome, Sriram.
Thank you, Hema.
Sriram, it would be good if you can introduce Arna Networks and what you guys are doing on ONAP perspective.
Sure. Arna Networks is a startup that's working on a platform that essentially tries to automate a lot of the functions of the 5G, cloud native functions of 5G and edge applications. So essentially that involves automation, lifecycle management, and creating the control loops for making changes in the configuration. So that's the platform that we're trying to create.
Thanks, Sriram. Sriram, let's start with introducing what exactly is physical network function. We've heard a lot about virtual network function, and we know that physical network function is going to stay here beyond the transition phase to 5G. So let's start with defining what is physical network function.
Sure. So essentially there are two categories of these physical functions, right? So one is physical functions are the devices that cannot be virtualized, right? So if you take any sort of a modern cloud native functions, right? A lot of the functions are virtualized either as VNFs or as CNFs, right? The VNFs refer to the virtual machines and the CNFs refers to the containers, right? So the idea is to make it more flexible so that people can create these functions quickly and make changes and so on and so forth, right? So that's happening. So while that is happening, there is a class of these devices which cannot be virtualized, right? For example, if you take the 5G specific use case, right? The 5G base stations. So you cannot, that's a function that cannot be virtualized. Right? So they will remain as physical functions, and they are an important part of the overall service, right? Because when you create a service, it will have virtual functions, CNFs, and the physical functions, right? So that's one class. The second class is there are a bunch of devices which have not yet migrated to the virtual functions, right? So these could be some legacy devices like routers, which are high performance and ASICs and so on. So people don't want to migrate them to virtual functions. So in that case, you want to keep them as PNFs. Now the importance is that even though your entire network service is virtualized or containerized, there will continue to be these physical devices which will stay as PNFs. So that's the importance of having these PNFs.
Understood. So, Sriram, one of the things that we always hear about is PNF lifecycle management, or how the orchestrators, whether it is ONAP, whether it is OSM Mano, or whether it is a vendor-specific orchestration or management functions, they always talk about BLF management. Now, how do you automate PNFs? Is it a similar capabilities? What objects you automate? So can you elaborate on that?
Sure. So essentially there are three aspects that you have to look at from a PNF's point of view, right? So one is to onboard them. The PNFs, there could be, thousands of those PNFs out there. And obviously, onboarding them manually by the operators is going to be very tedious and very time consuming, right? So that's the first aspect, which is to onboard the PNFs. So in that sense, it's kind of similar to the way you onboard the PNFs, right? So, but these are all physical functions that are there out there in the network service. Right? And as kind of a second part of that same functionality is that the PNFs may migrate. Right? For example, you may take a physical device and move it to a different location. So in that case, it has to be automated or reconfigured. Right? So again, all these functions can be done manually, but it's going to be extremely tedious to do that. And also, as in case of 5G, the problem is going to be a lot more. It's kind of orders of magnitude more because of the number of such devices will be more, the base stations and so on. Right? So that's the first part, which is to automate the onboarding part.
Okay.
Right? And the second part is automating the configuration, right? Because all these PNFs, all of them may not have the same configuration. Right? So you have to configure certain set of PNFs with certain parameters, and then another set with another set of parameters, depending on the location or whatever, in case of 5G, for example, right? And also they may change over a period of time. Right? For example, when you initially configure them, which is called a day zero configuration, right? You may have certain parameters.
Yeah.
And then as as you gain more experience, and you may have to tweak certain parameters. So these are day one, day n type of parameters. So again, all of them have to be managed either as a cluster or individually. And again, the same point, right? So all of them can be done manually, but it's going to be extremely difficult for operators to do that without automation. And the third aspect is kind of related to the second one, which is to automate the changes based on certain changes in the environment. For example, there could be more load, right? A particular station may suddenly receive more load because of some event or something, right? Or there may be some errors because of which you have to make some adjustments to the PNF's configuration. And again, it's extremely difficult for somebody to sit at a terminal or a management station, look at all of these and make these changes. Right? So this process has to be automated, where you may receive these errors, you may receive these parameters, and there may be some analytics functions which looks at all of this, analyzes them, and says, hey, you need to go change all of these set of parameters on these physical functions, right? So in that sense, the requirement is very similar to, for example, the BLFs or CNFs, right? So even there, you do exactly the same thing based on certain environmental variables. You will have to change those parameters, right? So that's exactly what these automation platforms will enable you to do. So you can create what's called as a control loop, where you receive these parameters, and then you run certain analytics, which could be either developed by the operators, or they could be from other vendors, and then they run them, and then based on that they go and make the changes. So that's the third aspect of the PNF management, where you will have to automate these aspects.
Understood. Sriram, one of the things that you already hinted on the previous question was about the onboarding part. And we've seen whether it is ONAP, whether it is OSM Mano, the focus is always on how do you pre-onboard, how do you actually onboard, of course, the discovery process and the entire lifecycle management. How is that similar to what we do on PNF? What are the differences when it is in context of PNFs? And how do you handle all the scalability issues and the related challenges?
Sure. Yeah, so I can probably describe the process in the context of ONAP, but it will be very similar for other automation platforms as well. Okay. So the first step is to pre-onboarding, right? Pre-onboarding the PNF. So in this case, essentially what you do is that's typically something that the PNF vendor has to do, right? Because if you are, let's say, a vendor of a base station or some specialized network equipment, so you are the one who is going to be creating what's called as a PNF descriptor. Right? Yes. So this includes all the artifacts for managing the PNFs, and how do you set certain parameters? What are the models that are required to manage this PNF? Right? So all of that is part of what's called as a PNF descriptor. Right? So that is the pre-onboarding step, where even before you actually bring it to some automation platform, you have to create this PNF package, which is again kind of similar to the VNF packages, right? So the considerations are very similar, right? The second step is to onboard and do the design, right? So again, a platform like ONAP has a very clear delineation of a design and a runtime, right? So, and the same thing applies to the the physical functions as well. Where, in case of PNFs, what you do is you essentially onboard these PNFs.
Yes.
So whatever package that you get from the vendor, you onboard it, make sure there are no errors and so on. And then, you upload these packages to the design, whatever is your design controller. In case of one app, it's SDC. And then you also do the network service. Right? So the service may consist of some VNFs and a combination of VNFs and PNFs, for example. Right? So you'll have to put them all together, create a service which kind of makes sense for you to start distribution and other steps. Right? So in that sense, it's kind of a subset of what you do in case of VNFs for PNFs. And the third part is the runtime, of course, right? So once you do the design and your PNF is kind of known to your platform, right?
Yes.
And then the PNF registration starts. So where, let's say a device is turned on, right? So, and then it tries to register. And there is a process for doing that. So it's a kind of a well-defined protocol where the PNF registers, and there are certain components in your platform which will receive it, and then it will configure it, and it will activate the device. So again, going back to the previous discussion, right? So the whole the idea is to automate all of this. So it's not like somebody's going to sit there at the terminal and management console and going to do that as PNFs come up, because there could be thousands of them that will come up, right? So that process again is kind of fully automated, right? So that's kind of the three important steps. Now the subsequently, right? So there are additional things that are possible to be done, to be automated. Right? For example, ONAP defines this process of plug and play.
Yeah.
Which is kind of an extension of what we talked about in the runtime. So the entire discovery process is fully automated. So there's a well-defined sequence where that when the device is turned on, it sends certain messages. In case of one app, these are REST messages. And there's a module in one app that receives them, and then it goes through certain. It looks at its own internal databases. So all of that is kind of a well-documented procedure, which for example, the PNF vendors can just leverage, so they don't have to develop anything extra for this. Right. And then there is the configuration, the ongoing lifecycle management. So the LCM refers to the lifecycle management, right? So that includes configuring it from day zero all the way to you decommission the device. Right? So first thing, you commission the device, configure it for the first day's operation, right? And then you keep modifying it depending on the needs, as we talked about earlier, right? So so that also kind of leads to the last one, which is creating the control loops or closed loops. So essentially what you do there is that this configuration or LCM process can be fully automated, right? So based on certain changes that happen in the environment, let's say you're error because of errors or because of load or because of any other situations which are kind of seen by the operators. Based on those events, you can make the changes to these devices, and also the LCM is a little broader than just configuration. It also means upgrading the software of the device, upgrading or maybe even downgrading, decommissioning the device. So all of that is part of the lifecycle management. So these are all the parts that are required to be done from the time that the vendor kind of designs the device and creates its own descriptor, all the way to the time that you actually deploy and then keep it in operation, and finally maybe even decommission the device. So the entire cycle can be managed with very little manual intervention. So that's the whole idea of this whole process.
Hey, Sriram, when we talk about BNFs, there is also a concept of BLF Manager. Most of the time, you see that the vendors who bring their own BNFs also have their own BNF Manager functionality. Is it similar to what we have, like in PNF world? If you come from a legacy perspective, there is a concept of EMS and NMS. So how does this all play into when you talk about pre-boarding PNFs and when you're doing the packaging? Can you elaborate on that as well?
Sure. Yeah. So there are multiple ways you can manage a PNF device.
Uh-huh.
For example, platforms like ONAP have controllers. So these controllers have different ways of managing either PNFs or VNFs. So in that sense, it's very similar.
Yeah. Okay.
For example, you can manage them over netconf, which
Yes.
is a very standard way of managing these devices, either PNFs or VNFs. Or you can have some Ansible playbooks to run to do some configuration, or you may have a chef, or there are various ways to do these configurations. So in that sense, it's the way you do the management of PNFs is similar to the way you do the VNFs. So you go through the controllers. You can use different ways of managing them using the standard mechanisms. And that's how the PNFs are handled.
Understood. Shivam, you hinted on the previous question about PNF plug and play, and again the key aspect is how can you reduce the OPEX. So do you want to elaborate a little more when you talk about the discovery process and plug and play? What exactly it encompasses?
Sure. Yeah. So the PNF plug and play is essentially to make the process as seamless as possible. So with kind of a close to a zero touch type of operation. So the first step we talked about already is PNF modeling. So you create a descriptor, you onboard it, so you do all of that in the design time. So at that time, what happens is that the details of the PNF are also registered in the local databases. Where the platform maintains them. Right? So, and then the runtime starts, which is really where the plug and play comes into play. Right?
Yes.
So the first is an instance declaration, right? So let's say you describe the PNF, right? So it has its own characteristics. Now, an instance is one particular instance of that PNF coming up, right? So the PNF comes up and somebody turns it on, right? So, and then the rest of the process is fully automated. So the PNF sends a message to the platform, so in ONAP or any other platform, and then the entire bootstrapping and the discovery through the registration, all of that happens by a well-defined mechanism. Right? Now, obviously there are a lot of details in that which I'm not going to go into. Into the sequence of operations that happen. In case of ONAP or any other platform. But the point here is that what it's going to help is, as you mentioned, right, about the OPEX, especially in a 5G RAN devices, right? So again, considering that compared to 4G or the previous generations, the number of base stations are going to be almost tenfold more, approximately. So you can imagine the amount of additional OPEX if you don't have any automation for all of these functions, right? So that's essentially the motivation behind making all of this as fully automated as possible.
Shiram, you also touched on the PNF lifecycle management. I think audience is pretty much familiar on how do we manage the VNF lifecycle management, how do you really scale up and scale down depending upon the needs. How would you describe the entire lifecycle management process for a PNF? We can take a own app as an example
Sure.
from orchestration perspective.
Yeah. So like we talked about, right? So in most of the cases, PNFs can be handled similar to VNFs. So in fact, in a lot of the one app terminology, they are just called as XMFs. Right? So PNFs or VNFs or CNFs. A lot of the operations, at least the goal is to keep it common. And obviously, some cases there will be differences, but to a large extent, it's similar.
Okay.
And in case of one app, there is a concept of controllers. Right? So, and there are multiple controllers in one app. And these controllers can support multiple protocols to manage these devices, be it VNFs or PNFs. Right? So, in the context of PNFs, it's again, if the PNF device supports, for example, netconf XML.
Yeah.
Right? So you can use any of the controllers in one app to manage or to configure or to perform all the lifecycle operations of PNFs. Right? For example, the CDT or AppC is one of the controllers, and it supports multiple ways to manage these or configure these devices, and all of them can be used for PNF as well. Similarly, SDN controller or CDS, which is a controller design studio, has a similar mechanism where you can have multiple ways to manage your devices, including PNFs. So in that sense, the considerations are very similar, but obviously, being a physical device, there are certain things that that don't make sense, as in case of VNFs or CNFs. Right? For example, there is no concept of scaling out a physical device because it's a physical device, right? So you can't just spin up another virtual machine and scale out.
Yes.
So those things are not applicable for PNFs. So barring such differences, a lot of the other things can be common. For example, if the PNF device can be modeled using a YAN, which is one of the sort of popular models to model your network device, right? So if it's modeled using YAN, you can pretty much manage in a way similar to the way you manage a VNF. You can change its parameters. You can maintain multiple copies of these parameters. So all of the functions that you can normally do for virtual functions can also be done for physical functions. And the same thing applies to the control loops. And we briefly talked about in the previous slides. So again, you can create a control loop which is very similar to the VNF's control loops, and then update the parameters or change anything on the PNFs and so on.
Sriram, one of the key things, like from a PNF perspective, and when we are talking about automation in context of 5G, how would you summarize the benefits as well as what are the key challenges that you see on a day-to-day basis? Like one of the key challenges that when I speak to customers is, yes, we spoke about YAN, we spoke about netconfig, but there are a number of legacy devices which do not support the standards. They still dependent upon CLI. So we talk about automation and all, but at the same time, we know that there is a legacy network. You don't have support for standards, and you feel, there will be a good number of challenges in order for them to automate the way you have described here. Can you elaborate? What can be automated, like you already explained, but what are the key benefits and what are the challenges that still need to be overcome?
Sure. Yeah, I think most of the devices support some of these protocols that we talked about.
Yes.
So in case some of them don't support, there are ways to sort of creating some kind of proxy mechanisms or creating your own plugins to enable these platforms to support these kind of legacy devices.
Okay.
So there may be a little bit of a customization that's required. If it is something that doesn't support any of these standard mechanisms.
Mm-hmm.
But to a large extent, a lot of this, the whole idea is that most of these standard protocols are supported, so that it's possible to sort of onboard and manage them without doing a lot of the custom work. That's the whole idea, right? But you're right. I mean, in some cases there may be devices that that don't support some of these protocols. So there may be a little bit of a custom development that may be required to support those physical devices. So that's kind of that may be one of the challenges in supporting it.
And would you mind spending a few minutes to again summarize the benefits, specifically PNF automation in context of 5G?
Sure. Yeah. So just kind of going back to kind of a brief summary of where things are, right? So the automation actually starts from the time that you onboard a device, right? So there can be thousands of these devices, and particularly in the 5G world, considering that these base stations are going to be more. So we will definitely require automation to support all the phases, right? Not just onboarding, but also continuing to configure them, right? So just to summarize, the steps are: first you make sure that the device comes up, it's onboarded, it's recognized by the platform, and then there is a descriptor that the vendor provides using which the platform knows how to manage it, right? So that's the first part. And then continuing to manage them during its life cycle, starting with the day 0 to day n configuration. And the third part is to make the changes based on the changes in the environment, which is the control loop. So these are kind of broadly the three areas, right? Onboarding, configuration, and then creating these control loops for automation of the changes. So that's kind of the process that's required for PNFs to be orchestrated and managed. And again, just to summarize the importance of automation, all of these steps can be done manually, but it's going to be just not scalable. So that's the importance of the automation in this case.
Good. Thank you, Sriram, for this very informative session. We really appreciate your time and looking forward to speak to you again soon. Thank you again.
Sure. Thank you.